So we are continuing with paper 2 from 0625 IGCSE Physics. This is the MCQ paper for the extended syllabus. We've done 26 out of the 40 questions. Here's question number 27, guys. The diagram shows a bar magnet and 4 plotting compasses. Which compass correctly shows the direction of the magnetic field due to the magnet?
Can you explain this question again?
So there's a bar magnet, right? As you can see in the center, right? The north and the south poles are labeled. Now, if you remember, when you place a plotting compass, the plotting compass also has a small magnet inside it, and that magnet is attached to the needle, right? So what it does is it shows the direction of the magnetic field lines. Now, the magnetic field lines, right? Which direction do it travel in?
The magnetism, I
P.
think,
Where? Which direction do magnetic field lines travel?
away from North Pole and towards South Pole,
Away from the north and towards the south. Which direction?
outside of the moon.
What? Yeah, yeah. Which pole does the arrow represent on the compass? Forget the bar magnet. If you just had the compass and you had it pointing in some direction,
A.
answer
B.
my question first.
Okay.
If you have a compass, just a compass,
Yeah.
and it's
Yeah.
O.
pointing in a certain direction,
Yeah.
what direction would that be?
North.
North, right? Of course, you have to align the compass with the north on the compass with the needle and everything, but the needle signifies north. Now, knowing that the needle signifies north and that there's a magnet inside the compass and that the magnetic field lines go from north to south, what would your answer be?
B.
No,
Like that arrow would be representing south now.
the arrow. Acha, see, the problem is right, that there is a magnet inside the compass. If you right, normally if you use a compass to find location, right, it is attracted towards the geographical north of the earth. But if there's an actual magnet nearby, then it is influenced by the magnetic field. Again, I'm repeating this point, there is a magnet inside the compass.
So A would be the answer.
No. Soviet,
Okay.
Right.
what do you think the answer is?
Honestly, I'm confused. I don't think it is D or C, but I'm confused between A and B.
But I've already told Haram that it's neither A nor B.
So it's D.
It is D.
B or D.
D for, you know,
Dance.
dandelion,
Okay.
right? It's D. Why? Because again, there's a magnet inside the compass, right? It is being influenced by the magnetic field. The magnet inside the compass also has a north and south pole, which means that its south pole will be its north pole will be attracted to the south pole. It will be pushed from the. So if you remember, we did that plotting a magnetic field line on a bar magnet. I also showed the video, and what you do is when you place the plotting compass towards the north pole, it points away from the north pole. Why? Because the north pole of the bar magnet is repelling the north pole of the magnet, and so the needle will point away from the north pole, not towards it, right?
Yeah.
So if in B it was pointing towards the opposite direction, in fact, in any of these, if it was pointing towards the opposite direction, right? In fact, these would be slanted. In positions A and C, it would be slanted towards the south pole, right? B should have been in the opposite direction.
Like it would have been going to the uh, right side.
Yeah, right. So the only correct answer is D because the north pole of the magnet inside the compass is being attracted to the south pole of the bar magnet.
So starting from south and it's going towards north.
No, it starts. The magnetic field line starts from north. When you place the compass at the north, the compass actually points away.
Okay.
right? And as you keep placing it, you can revisit that class of ours, and I share that video with you. So the video link is also in my recording. I've put a, what do you call that, card, right?
Okay.
So you can look up that particular class of ours. I have each of the classes, I've mentioned the topics we cover, so you can look it up, right? It's in the beginning of unit 4 when we talk about magnetism, right? And
Okay.
so you can revisit that concept, but the point is that the answer would be D. Okay.
Like let's say in B, it is like pointing towards the south, and the pole is north. So
It's not pointing
it's in
towards
like,
it. In B, it's not pointing towards the south. It's pointing towards the north because you're that close to the right north pole.
okay,
So yeah, so that's why it's wrong. You're not going to say, oh, it says north, magar ye hai, behind that it's south, so it's pointing towards the south. That's not how it works.
okay.
All right, question 28. When, sorry, not when, a plastic rod is rubbed with a cloth, the rod becomes positively charged. What happens to the plastic rod and what is the charge on the cloth? Should be easy.
D.
C.
C. Haram, why D?
Because like the rod is positively charged, so it is losing like electrons, not.
Exactly,
And
yes.
if it's losing electrons, the charge would be positive.
The charge on the cloth, not on the rod.
Okay, it would be C.
Yes, so always read very carefully. Right? Don't be in a hurry. Do not be in a hurry. Right? You need to obviously increase your speed, but again, right? 40 questions in 45 minutes, so it is a race against time, but that does not mean you are careless. All right. The electromotive force of a mobile phone battery is 3.7 volts. What does that mean?
E.
A. This one is from memory, right? If you know what the definition of EMF is, then you should be able to.
C.
You sound doubtful.
Going towards gut. So,
Going towards cut, right? Haram, you're sticking with A. Are you there?
yeah, she's there.
Yeah.
Okay, so Sobia, right? Are you familiar with Star Wars?
Yeah,
Right? You've heard the phrase "the Force is strong" in this one.
I have heard now from you.
Yes, so I'd say the gut is strong in you,
Oh,
right? So the definition of EMF is the amount of energy required to drive a charge around the circuit, right? I have the textbook open over here.
so am I wrong?
You are correct.
Oh, okay.
As I just said, the gut is strong in you,
Yeah.
right? So electrical quantities somewhere over here.
Electric motive force.
Yeah, so just getting the EMF, yeah, over here. So the EMF, or electromotive force, is the electrical work done or energy, transferred by a source in moving unit charge around a complete circuit. Right? So whatever the EMF is, that means that is the energy required to move the charge around the circuit. And so if the EMF is 3.7 volts, that means 3.7 joules of energy, work done in energy of both in joules, is provided by the battery to drive 1 coulomb, that is one charge, right, around a complete circuit.
Okay.
So if you know the definition of what EMF is, you can attempt this easily. Okay.
Yep.
Yes.
All right. Question 30. A computer engineer wants the speed of a fan to increase when the temperature inside the computer increases. The engineer knows that a larger current causes the fan to turn more quickly. So you've got this circuit inside the computer, right? You've got a power supply, you've got component X, and then you've got the fan motor. And right, so the way this is right, current is passing from the power supply, right, through X to M and then back, right? That's how this is working. So he wants the speed of the fan, which means he wants more current to go to the fan when the temperature is increasing. So what component would X be that allows more current to pass through as it gets hotter?
B.
B, Sobius?
B.
Yeah.
Uh, Haram, yours was D or B?
Hers is
B.
Bumble.
B for both.
Bumble.
Yeah.
Yeah.
Yeah, I'll also go for Bumblebee then.
Yes.
Because it changes its resistance with like temperature.
Very good. Right. So you need to know the reasoning behind your own answer, right? And so a thermistor is a variable resistor. Difference is that it is temperature dependent, and as the temperature increases, the resistance decreases. And when the resistance decreases, more current is allowed to pass through, right? And so that is exactly what the engineer in this question wants. He wants more current to pass through when the temperature increases to increase the fan speed, right? Thereby keeping the computer cool. Okay. So if you have like a PC at home, or more likely a laptop, right? I mean, you could have a PC, obviously. Laptops are just more common nowadays. And if you ever notice the fan inside your laptop suddenly increasing, and you go like zoom, you hear like that thing in, right, speed up,
Yeah, yeah,
and you feel that your laptop's hot. That is
yeah.
how it's working. So if it detects, okay, the temperature is rising, the fan speed also increases to cool it down. And so that's why you need to place your laptop in such a way that its exhaust is not blocked. Right, so the exhaust ports are either on the sides or at the back, or under the laptop somewhere. And so you need to place it so that it can dissipate that heat. Anyway, good job. All right, 10 questions to go. We've got plenty of time. So a water heater is connected to a 230-volt supply, and there is a current of 26 amperes in the heater. Right? It takes 20 minutes to heat the water to the required temperature. How much energy is supplied by the heater?
You're gonna use the formula for electrical engine energy, right?
Yep.
We just have to multiply all the values. No?
Uh,
I mean,
kind of. Kind of.
voltage multiplied by current, which is I, and multiplied by time, which is C.
But
It would be B.
But
B.
shouldn't we convert the time into seconds first
Yes, I was waiting
for
for
the
that.
SI,
I was
for the
waiting for that.
standard SI unit?
So it will be 230 multiplied by 26 multiplied by 20 multiplied by 60.
Seconds.
Yes. And so what's your answer?
7.2 into 10 exponential.
Yeah, so it's actually 7.176 something, or if you just
Yeah.
spread it out, 7,176,000 joules. But
Yes, yes, yes.
yeah, but right, given the options, right, you round it up, and so it becomes
We have to do it
7.2.
in scientific notation.
Yes, significant, like standard notation, standard form. And so that's 7.2 into 10 to the power 6 joules. So that's option D.
Yeah.
Good. Question 32. An
How many
elect-
more are
yeah, go ahead.
how many more are left?
9, including question 32. So an electric kettle has a metal casing, right? The cable for the kettle contains a wire that is connected to the earth pin of the plug. What danger does this guard against?
B.
Yes, Sobia?
Thinking with. Let me look here. Don't rush me.
I didn't say nothing.
A? No, wait. Yeah, I think it's A.
And Haram, you say B, right?
Yeah.
Okay, so obviously it's not C, right? The wire has nothing to do with whether the kettle is wet or not. And is it going to protect it from overheating? So again, this is conceptual, right? What does earth do? What does the earth wire do, right? So it prevents any leaking current to cause the electrification of the appliance or the or the plug. And so any excess current passing through the appliance or the wire is directed towards the earth, which is called grounding, and so it's taken to the earth and protecting the appliance and the wire and therefore the user. So with that concept of earthing, it is given in your book, right? uh, at the end, I believe. So electrical safety, so electric shock over here, and they should mention earthing. So fluorescent lamps, house circuits, fuses, trip switches, earthing. There you go. Right? The earth pin on a 3-pin plug is connected to the metal case of the appliance, which is thus joined to earth by a path of almost zero resistance. If then the element of an electric fire breaks or sags and touches the case, a large current flows to the earth and blows the fuse. So therefore, it prevents the casing of the kettle becoming live. So it prevents the casing of the kettle in this case, and it has a metal casing, right? That's the problem. So it prevents the casing of the kettle to have electricity flowing through it, which would cause a shock to the user, right? Especially the fact that it is an electric kettle, so you're going to be putting water in it, which is worse. Okay, right, Sobia?
Okay.
Yeah,
So the correct answer is B. No?
the correct answer is B. Yes, B for
Okay.
Bumble.
Okay.
All right, an electric current can produce a heating effect and a magnetic effect, right? Which row shows the effect that a relay uses and one application of a relay?
Is C?
Haram?
C.
C? Both of you going for C? C is correct. So the first thing is you need to identify which effect it is, and so A and B are eliminated. Now between C and D, right? Does the relay allow the switching of a larger current, or does it allow the changing the voltage of an AC supply? So obviously that's not true, and so it's C. Yes, good. All right, question 35. I need to zoom out a bit for this. No, I can stay zoomed in. Okay. So the diagram shows a bar magnet and a coil of wire. The bar magnet is moved at the same speed in each experiment. So just keep that in mind. Speed is the same. In which situation is the largest electromotive force induced? So this is electromagnetic induction, right? You're moving a magnet through a coil, or you could also move a coil, right? You could also move the coil, or you could move the magnet, right? The motion needs to be relative, right? So it will cause an EMF in the conductor, and if the you know the ends are joined, it's forming a complete circuit. It will cause a current to flow through the coil, right? So which one would have the largest induced EMF?
C or D?
Okay, so
B.
Aram, and so like we can agree it's not going to be A or B, right?
Yeah.
Right. So yes. Now between C and D, right? For option C, the magnet is moving towards the coil is moving towards the magnet, the same speed, right? Okay. In option D, do you think anything's going to happen,
No,
right? I mean, D is just a ridiculous option, to be honest,
because
right?
nothing is happening in the coil.
No, I mean, right? The magnet will not interact with the coil because
Yeah, that's what I'm
you're
saying.
moving the magnet towards the left, and you're moving the coil towards the left at the same speed as the magnet, right? And so,
Yeah.
I mean, you're not going to get any induction, right? A and B, at least there is some induction. D is not going to get anything because you're moving the magnet away from the coil, and you're moving the coil towards the magnet, but they're not, crossing paths, and so there's not going to be any induction happening at all, right? It's like a kid playing with their, Hot Wheels or something, right?
Yeah.
With their die-cast cars, or dinky cars as they're called, right?
So C is the answer.
C is the answer. Why is it the answer? Because the magnet is like A and B, like
Interacting.
yeah, it's the same situation as E if you just look at the magnet, but then you're also moving the coil, so you've got twice the movement, right? So it's
Yeah.
double the movement, and so you're going to get more EMF. And then, going back to the theory that it is a law of conservation of energy. And why is that? Because when you're moving the magnet towards the coil, an opposite pole will form towards the coil, and so there's going to be repulsion, and so your kinetic energy is converted to electrical energy. And so if you've got double the kinetic energy, you're moving the coil and the magnet, and so you're going to get double the electric energy, which is EMF, right? So
Yeah.
option C is the answer. Okay, 35. Increasing the transmission voltage in transmission cables reduces power loss. What is the explanation for this reduction? Again, this is a conceptual question.
A?
Okay, Aram?
I don't know. Like maybe eight.
Hmm?
Maybe eight.
Maybe A. So A is correct. And so what you are looking at obviously is the formula for power, right? This is uh, covered in, right, transformers and transmission lines, which come in, right, 4.5 in the text. Yeah, the transformers. And
Yay.
yes, it is A, right? And they've got the transmission grid, and they're giving you the explanation why it's happening, right? So power loss in transmission cables. Uh, Power cables have resistance, and so electrical energy is transferred to thermal energy. And so, right, P equals to uh, what is it? Uh, VI, and V equals to IR, right? So P equals to I square R. In order to reduce energy loss, the current in the cable should be kept low, right? So voltage is high, current is low, right? And so you're losing less heat and less power. So yes, A. All right, last 5 questions. Question 36. So more for this one. Okay. There is an electric current in a straight wire in the direction into the page. This produces a magnetic field around the wire. Okay. All the field lines are circles, but only one field line is shown. Which row describes the magnetic field?
Eight.
A?
No, it won't be like anti-clockwise, no?
Huh?
It won't be anti-clockwise.
Why would you say now? I'm going to ask you why. Why won't you? Why won't it be anti-clockwise? And how will you first of all figure out whether it's going to be clockwise or anti-clockwise?
Because it will be equally spaced and it's going in like the clockwise direction. That is,
Okay, so which of the rules that we've learned are you applying over here?
considering that it is
I
about
know.
the speech line.
No, no, like in an exam.
Can I?
Yeah, of course you can.
Right hand grip rule.
Right hand screw rule actually.
Yeah. So the answer will be D.
Yes. Okay. So Haram, you didn't get to the answer, but you were correct that it won't be anti-clockwise. I was just trying to reason with you. You'll be using the right hand screw rule, right? So here the right hand grip rule is for solenoids. For a current, for the magnetic field around a wire, you use the right hand screw rule. So if it's right, so you curve your four fingers, you stick your thumb out with your right hand, right? The thumb points towards the direction of the flow of current, so that's going away from you, it's going into the page. And so you notice with your right hand, your fingers will be curving clockwise. So that gives you either C or D, right? So Haram, you were correct about that. Now, whether it's
So
going to
let
be
me
C
speak.
or D, right, depends on the how the field lines are. So will they be equally spaced, or will they be more widely spaced further away from the wire? So we know, right, for the magnetic field or even the electric field, right, they are more dense near the source, and as you move further away, right, they become spaced out, and so the effect of the field decreases. That's also true for gravitation, right? The closer you are to the source of gravity, which in our case is the Earth, the stronger the gravitational field, the more gravity, the more effect of gravity on us, The further away we go, like satellites, and if you like way away, the gravitational field lines are less, like they're more spaced out, and so the lesser the effect of the gravity. So that is true for any field, right? The closer to the source, the more packed they are, the closer they are. The further you move away from the source, right, the more spaced out they are. So, given all of that, it is option D, the last one. Okay. Now, nuclear physics. So, the diagram shows emissions from a source passing into an electric field between two charged plates, right? You have one that's going straight through and the other that is curving which arbor?
Mm.
Alpha particles would be emitted.
I mean, it could be alpha particles, it could be gamma rays, it could be beta particles, it could be any which combination will give you the kind of effect that you're seeing in a uniform electric field.
A or B.
B,
C.
A or B.
C.
C, or D. Okay, now, right, C and D are very different. So one thing you've got common over here, right, is the line that's going straight, right? Which what emission is the straight line? Just the straight line. What emission is the straight line?
I
Wait.
think
Mine is B, and the straight line is like the alpha particles.
Okay. Now we need to revisit the you know radioactive emissions. Alpha particles are similar to helium ions, right? That have lost both
C plus
electrons,
2.
and so it has a double positive charge. Beta particles are high energy electrons, and gamma rays are not particles, but they are electromagnetic radiation, right? You have some of these emissions coming from the source, and they're passing through an electric field. So I asked about the straight line. That's going to be gamma rays, right? Why? Because it does not have a charge. It is an electromagnetic form of radiation, right? And it's going to pass straight through. It's not going to be affected by the electric field. Okay. Then
So
we
it's so,
then we come to the curving line, right? Now you can see it's curving away from the negative, pole, and towards the it's curving away from the positive pole. Sorry, away from the positive pole of the electric field towards the negative pole, right? And so that means it is being repelled by the positive pole. It is being attracted towards the negative pole. Now, which of the alpha or beta particles will be repelled by the positive pole?
yeah.
No,
So it's gonna be C.
yes, because the alpha particles are helium ions. They are positively charged, and so when you got a positively charged particle in an electric field, it's going to be repelled from the positive terminal, and it's going to be attracted towards negative terminal. Okay. All right, so you need to know the properties of these emissions. Now, it's not going to be A at all. You'd say, well, neutrons are all, first of all, neutrons are neutral, right? And so you'd have two straight lines passing through, right? Because gamma rays are also neutral in that sense. And secondly, radioactive emission does not emit neutrons, right? It's either alpha particles, beta particles, or gamma rays. Neutrons are not emitted, right?
yes.
Beta decay, neutrons are converted to a proton and electron, but the neutron That's right. It's converted to a proton. The proton stays inside the nucleus, so it's not emitted. The electron, the high energy electron, is what's emitted, which is the beta particle. Okay,
Yeah.
almost done. Question 38. Which row in the table describes the process of nuclear fusion and identifies the change in the total mass of the particles involved?
E.
Beta, it's nuclear fusion.
Oh, okay. Alright. Mm-hmm.
Yes, Sobia?
Mm, C.
Okay, so because it's fusion, we know it's going to be either C or D. Right?
Yeah.
Two small nuclei combine to form a large nucleus. So that's fusion, right? A large nucleus splitting into two smaller nuclei is fission, right? So we can eliminate A and B just because it says nuclear fusion. Now, whether it's going to decrease or increase, let's take a look at nuclear physics. So here we have nuclear fusion. And so the thing to look out for, right? You've got two smaller nuclei, right? And you've got deuterium and tritium, and they're combining to form helium. And so law of conservation of mass, you've got a atomic mass of 2 over here, atomic mass of 3 over here, so that should make up 5. Each have one proton, and so for helium you see it has the 2 protons, so that's fine, but the atomic mass of helium is 4. You have 5 over here, and so what's happening is one neutron is being lost, right? And so according to that, the total mass of of the nucleus is decreasing. Why? Because if you take a look at the total mass of these two guys, it's 5 atomic mass units. Whereas the mass of the helium nucleus is 4, so it's actually gone down. So even though it's tempting to say that it's going to increase because you're putting two small things together, so right, like 2 plus 3 is 5, it's yes. But keep in mind that you're also losing a neutron, and so the total mass of the particles is actually going down. That's why the option is C. Okay.
Okay.
Yeah.
Okay. Question
The
30.
correct
Yeah.
option is D.
Huh?
So the correct option is D.
C.
Okay.
C. All right. The orbit of the moon around the earth is modeled as a circular path of radius 3.8 into 10 to the power 5 kilometers. The orbital speed is 29.5 days, right? What is the,
Distance over time.
sorry, the orbital period is 29.5 days. What is the orbital speed of the moon?
Option D.
Option?
D.
All right, so how did you get that?
I use the distance over time equals to 2 pi r over t.
Hmm.
Am I wrong?
2 pi r over
T.
t,
Time.
and t is 710, right?
Yeah.
All right, so you did 3.8, so that's 380,000 multiplied by 2 multiplied by pi,
Yeah.
right? And that gives you 2,387,610.4 something something something,
Exactly. Yeah.
and you divide that.
With 710.
Yes, and you get 3,362.8, which is
Yes.
right 3.4 if you round it up into 10 to the power
Yes.
3 kilometers per hour, which is the correct answer. Good. By the way, we didn't even ask for Haram's response. Haram,
Would be some next answer here.
huh?
It would be D.
It would be D, right? Okay, last question. Which statement does not describe redshift?
Oh,
Not. So you're looking for the wrong answer.
a little brief on redshift, if that's
So,
possible.
so when an object emitting light is moving away from you, right? Red has the longest wavelength. So,
Yeah.
right, when an object is moving away from you, even though its wavelength is what it is, whatever light it's emitting, because it's moving away from you, the wavelength appears to be longer than it actually is, right?
Yeah.
And so it appears to be red. The light that's coming in appears, for emphasis on appear. It appears to be red.
A or D.
Um, A. I mean, it wouldn't be C, definitely.
Look, you're looking for the wrong answer,
Yeah.
right? You're not looking for the right answer. You're looking for the wrong answer.
Yeah. Yeah, I'm gonna go for A.
Yes, Haram.
D.
The light from stars in all distant galaxies is moved towards the red end of the. That is exactly what redshift is.
Yes.
So that's the correct answer. We're not looking for the correct answer. The light arriving at the Earth. So let's look at B. The light arriving at the Earth from a receding. Receding means something that's going away from you, right? From a receding star is always redshifted. Yes, that's true. During
And
redshift,
C
the
is,
wavelength of the observed light is longer
yeah.
than it is if redshift had not occurred. That is also true. All of these are basically
Yes.
saying the same thing. B, C, and D are saying the same thing, right?
So
That
A
the
is
observed,
answer.
yeah. So the wrong answer, right, which is what you're looking for, is A. All the light emitted from all distant galaxies is at the, is so what they're saying is that the light is red to begin with, and that's not what redshift is. Redshift is, it might be blue, it might be yellow, it might be like some other color, right? But because the galaxy or the star or whatever it is that you're observing is moving away from the Earth, it appears to be red, right? It's not actually red. It could be, yellow or blue or white or whatever. It appears to be red. Okay. And so
Okay.
what option A is saying is that all the light coming from distant galaxies is red, is at the red end of the spectrum, is red light to begin with, and that is not true. Okay,
Okay. Yeah.
Yeah.
right? Okay. So with that, we are done with our round through the paper two of IGCSE. So next time I'll see you guys, which will be after Eid, inshallah. And right, we'll pick up with paper 4. So that will be the extended theory paper,
Okay.
right?
Okay.
All right. Have a good break. I'll see you guys next week, inshallah.
Inshallah. Allah Hafiz.
Allah Hafiz.
Allah.